All right, folks, I want to talk about server-side template injection because this was a lot of fun. I learned about this from a single tweet. I was on Twitter one day and somebody posted, "I've figured out a new way to make a reverse shell with SSTI." And he had this long line of like 3 lines of code that looked kind of like a big long SQL injection. And that got my attention. So I went and started working on this. And I learned how this works. So here's what you got, and you're going to make your own server if you follow this project on a Google Cloud Debian server. But I have a vulnerable server running for the later part of it here, which I'll use to show you the essential problem. And see, a lot of people complain about my website because I learned how to write websites in the early 90s, and I still make them the way we did it back in the old GeoCities, where I just write HTML in a text editor, and that's it. There's just one page with images on it just sitting there. It's not customized or anything, doesn't use any JavaScript or anything. It's really primitive stuff. And in the modern world, people have switched to these customized web pages like Amazon. If I go to Amazon, I'll see a different page than anybody else that goes to Amazon. It reads my IP address, my location, cookies on my machine, and it customizes the page. So when you design a web page these days, you don't just write an HTML file, you write a template like a form letter, and then it ties into a content engine that fetches data from a database and fills it in. So here's a simple case. This is going to do some kind of search. And if I search for wet, it finds wet. It's always going to tell you this user exists because this is just a simple simulation. There's no actual database. It just assumes that whatever you're looking for was found. But the interesting thing here is this is working by templates, server-side templates. And that means you can put in data like this. You can put in information in these tags to indicate a field to be calculated. And that is here. Double curly braces with 2 times 2 in it gives you 4. So now, once again, this is command injection. I was only supposed to put in data like a name, but by adding special characters, I was able to put in a command to be executed, where it multiplied 2 times 2. Now that doesn't seem like much of a risk. If I can do simple arithmetic on the server, what does it matter? And it turns out to lead to total system compromise because of Python 3. Python 3 is fantastically risky if you don't filter the input because of the way its object-orientedness works. Anyway, here you can fingerprint your server. There's a series of tests. There are about 7 common engines used for this on web pages, and you can fingerprint which one you've got by going through this chart. So if I move this over here, I should probably, yeah. So if I do the first one with 7 times 7, and that's of course the same as 2 times 2, but the interesting thing here is I only use one set of curly braces. So if I put that one in with only one set of curly braces and search for it, it does not perform the calculation. It just echoes back the name I put in. So this test failed. If execution had succeeded, I'd follow the green arrow. If it fails, I follow the red arrow. So now I try using 2 sets of curly braces, and that's where we started. We know that one's going to succeed to evaluate 49. So we follow the green arrow, and on you can go to determine which template is being used on the server with this flowchart. So that's one thing to do. And now to understand the vulnerability, I want to explain how this works in Python. So I'm going to use my Cloud Linux server, which is what I love to use for pretty much everything. So I don't have to have any local virtual machines or anything. This is just a Debian Linux server. And I can run Python 3 on it. Now I can execute commands here. So if I put in a simple string, like this, s equals hello. That creates an object named s, and it is a string object. I'm just adjusting the size and such to try to make this easy for people to see in the video. All right, so now I can do a directory of s. If you create a string in Python 3, it's an object. And you can do all kinds of things with that object. That object has attributes and methods. So for example, it's got a method called upper. So I could do s.upper, And that would give me the uppercase, and I think it's got lower too. So this, again, might seem harmless, but it's not. When I just create a simple string object, like I read a string from the user to be a username or a password or something, it's an object, and there are things you can do with it which involve running code on it that come from the system. And so you can run this one, you can run class, and that will tell you what class of object it is. It is a string. All right, that's not really a surprise, but it turns out that you can move up even higher. You can walk up the hierarchy of Python 3. It is a tree-structured series of objects. So I can take S class, and I can take the class of that. And that is type. So the string, the class of S is string, and the class of string is type. Okay, I can also use base instead of class, a different way to move up the hierarchy. And the base is object. An object is the actual top of the Python 3 tree. So here's how it looks. I started with a simple string. By doing S class, I go up to the class of string. S class class is the class of type. S class base is object, and this is the root of the entire tree. Now what's going on is, in this website using template injection running in Python, I can inject a string, and the string is processed. But the question is, suppose I want to do something like open a reverse shell. I want to make a TCP connection from that to my command and control center and execute a shell so I can execute commands on the server. Can I do that? Well, probably not, right? Because this template injection probably didn't even import any of the libraries that make network connections. Why would it? But it turns out that it does not matter what libraries the developer imported. I can import new libraries. Because if I go up the tree to the top of the object, I can then come down and I can look for sub methods that can be executed on an object, and I can find one of them that has the ability to import libraries. So I can do this. I can go up 2 steps and then down 4 steps, and I can import a library, and then I can import the OS system library, and now I can execute a bash command. So this is what got my attention. So you can make a long mesh that will let you then execute command lines on the server. And so it's good, clean fun. You can get code execution eventually down here. I can now execute the date command in the bash shell from inside Python 3, starting from a string by walking up and walking down. And you can do it on the server this way. So I can put in things like this. I can inject not just the 7 times 7, but I can do all of that here. A string.class is now type string. So inside this web form, I can do the same kind of nonsense. And so you'll end up with very long injections. Things like this. This takes you all the way up to the object at the root of the tree and shows you the subclasses that are available to it. These are all its methods and attributes and methods that are available for that object. And one of them will take you, you can even make loops and so on to hunt through it. So if you follow through this, it's amazing. You can eventually execute arbitrary commands on the server this way. So it's a good, clean thing to try out. And of course, as in a previous class I was teaching this, a student said, oh, in principle, just like SQL injection, you could prevent this by filtering so you don't let them put in those curly braces in the username. And that is probably true, although in general, such bad listing, where you try to stop the bad characters, is risky because clever attackers find more and more sneaky ways to encode the bad characters and sneak them in again. But anyway, that is the simple input filtering is obviously the simplest way to defend yourself from this. So you should check that one out. I'm going to stop this video.